Hello everybody, let us dive in pre-mock set 1 2026. This is one of the papers you have to really have a good concept of. You need to understand it very clearly. Now we're going to be looking at item 1 episodes. Keep tuned. Now, before breaking down for you this item part by part, allow me read it for you. The question says, item 1, a district water authority is installing an automated monitoring system at a newly constructed water treatment plant in Mbarara City. During testing, engineers discovered that the sensor controlling the water flow rate operates correctly only when parameter x satisfies the equation x squared minus cos x is equals to 0. To avoid delaying the commissioning of the plant, a trainee engineer suggests first determining the interval containing the positive root of the equation and then using one application of linear interpolation to obtain an approximation value of x. However, the chief engineer recommends refining this estimate using the Newton-Raphson's method before approving the sensor for operation. Now, according to the plant's quality assurance guidelines, the sensor may only be commissioned if the percentage error in the estimated operating value does not exceed 0.5% when compared with the accepted value of 0.824. That is good. The task says that A, assist the trainee engineer to determine the interval in which the operating value of x lies and obtain an approximated value of x. B, assess whether the sensor should be commissioned. That is good. Now, when you look at the item, problem 1 from the item says that sensor works when x squared minus cos x is equals to 0. That one comes from the topic of numericals method, specifically location of the roots, where that is already they have already made it for you to be equated to 0. Therefore, you can let your f of x is equals to x squared minus cos x. Then you find the positive roots. Then that is how it is. You can find it. And then the problem 2 from that scenario, the trainee says, find interval containing roots. When we talk of finding intervals containing roots, we're going to need our a and b, whereby our f of a and f of times f of b should be less than 0. You know that thing. Then you compute it to find when your f is 0 and f is 1 from the methodology. So that is it. Then problem 3 from that same item is, trainee says use one application of linear interpolation to get approximation x. That one comes from linear interpolation, which all of us are at least related with that topic of linear interpolation. We use that methodology, we compute it to get the answer. Then problem 4 from that same item, chief says refine using Newton's Raphson's formula. Refine using Newton's Raphson. That comes from Newton-Raphson's formula. All of us are at least aware of that. And then we use the methodology, we compute it. Then the last problem that we need to solve or resolve there is, they're saying that for quality rules, check percentage error versus 0.824 must not exceed 0.5%. That one comes from the topic of percentage error. We use the methodology, we compute it, and then we justify it to conclude it. When I talk of methodology justification now, you usually in mathematics, when you're answering question, the first approach to the question is we interpret it. When we interpret, what I mean there is that what does the story mean in the mathematics? In mathematics, what does that story mean? You have to be able to you have to be able to interpret that. And then the second thing you have to have is the method. Which formula can I get it? Which means that you have to know where the topic comes from. Then you will be able to select an appropriate formula for that. And then the third thing that you're supposed to consider as an approach in answering the question is to compute. You should do the calculation, which means that you should know how the formula works. Then lastly, justify. Compare with the given limit and say yes or no. what the question has really want you to conclude with. So that is how it is. That's what justification. Then with that, you have made a very good report for your answer. So that is how the things are done in mathematics. So you should be able to do that to answer all this. So I hope I've interpreted for you this item 1. Please try it out with the problems I have broken down for you. Try to come up with a solution. Thank you.